Elastomer, Wikipedia audio. An elastomer is a polymer with viscoelasticity and very weak intermolecular forces, generally having low Young's modulus and high failure strain compared with other materials. The term, which is derived from elastic polymer, is often used interchangeably with the term rubber, although the latter is preferred when referring to volcanisates. Each of the monomers which link to form the polymer is usually made of carbon, hydrogen, oxygen, or silicon. Elastomers are amorphous polymers existing above their glass transition temperature, so that considerable segmental motion is possible. At ambient temperatures, rubbers are thus relatively soft and deformable. Their primary uses are for seals, adhesives, and molded flexible parts. Application areas for different types of rubber are manifold and cover segments as diverse as tires, shoe soles, and damping and insulating elements. The importance of rubbers can be judged from the fact that global revenues are forecast to rise to $56 billion in 2020. IUPAC defines the term elastomer as polymer that displays rubber-like elasticity. Rubber-like solids with elastic properties are called elastomers. Polymer chains are held together in elastomers by weak intermolecular forces. These weak binding forces permit the polymers to be stretched. Natural rubber, neoprene rubber, Buna S and Buna N are elastomers. Background. Elastomers are usually thermosets but may also be thermoplastic. The long polymer chains cross-link during curing, i.e., vulcanizing. The molecular structure of elastomers can be imagined as a spaghetti and meatball structure, with the meatballs signifying cross-links. The elasticity is derived from the ability of the long chains to reconfigure themselves to distribute an applied stress. The covalent cross-linkages ensure that the elastomer will return to its original configuration when the stress is removed. As a result of this extreme flexibility, elastomers can reversibly extend from 5–700%, depending on the specific material. Without the cross-linkages or with short, uneasily reconfigured chains, the applied stress would result in a permanent deformation. Temperature effects are also present in the demonstrated elasticity of a polymer. Elastomers that have cooled to a glassy or crystalline phase will have less mobile chains, and consequentially less elasticity, than those manipulated at temperatures higher than the glass transition temperature of the polymer. Natural polyisoprene, cis 1,4 polyisoprene natural rubber and trans 1,4 polyisoprene gutta percha, synthetic polyisoprene, polybutadiene, chloroprene rubber, polychloroprene, neoprene, baprene etc., butyl rubber, halogenated butyl rubbers. It is also possible for a polymer to exhibit elasticity that is not due to covalent cross-links, but instead for thermodynamic reasons. Unsaturated rubbers that can be cured by sulfur vulcanization. Saturated rubbers that cannot be cured by sulfur vulcanization. The definitions are not authentic as the rubber which is classified in World Customs Organization books in Chapter 40, whereas the above definitions stating all rubber and different polymers in same chapter which is classified in Chapter 39 of the World Customs Organization's Harmonized Commodity for Description and Coding System. One should go through all differentiation while editing between plastics and articles thereof and rubber and articles thereof. EPM and EPDM rubber, epichlorohydrin rubber, polyacrylic rubber, silicone rubber, fluorosilicone rubber, fluoroelastomers Viton, Technoflon, Fluoral, Aflas, and Diel, perfluoroelastomers Technoflon PFR, Calraz, Chemraz, Perlast, polyether block amides, chlorosulfonated polyethylene, ethylene vinyl acetate. Various other types of For's elastomers. Thermoplastic elastomers, the proteins resilin and elastin, polysulfide rubber, elastolefin, elastic fiber used in fabric production. Examples: